Okay, using partial fractions, we're going to take this fraction and split it up into separate fractions. So in this case, because the denominator is a linear times a linear squared, this is that third type that we saw in the previous video. So it's going to be some constant over x minus 2 plus some other constant times this linear, which is 2x plus 3, plus some other constant divided by that linear squared. And we've got three constants now, and that'll match up with the three coefficients. So this will work. So again, just as before, what we're going to do is we're going to take this identity, which is true for all x, and we're going to multiply it through by the denominator of the left-hand side, and that's going to give us 6x squared plus 13x minus 1 is identical to a times 2x plus 3 squared plus b into x minus 2 times 2x plus 3 plus c into x minus 2. So this term multiplied by this denominator, the x minus 2's will cancel top and bottom, and we're left with this on top. With this term, one of those brackets will cancel with the bottom, and you're left with that one and one of those. And then with this c, both of those will cancel with both of those, and we're left with just the x minus 2 on top. From this point, again, you can either equate the coefficients or you can use substitution. If you're going to use substitution, you need to substitute in three values this time. Choose x is minus 3 on 2 to make this and this 0. That'll give you an equation with c in it. Then choose x is 2. That'll make this and this 0. So that'll be an equation with just a in it. And then you need to choose some other third value for x. It doesn't matter what it is. There's no third obvious choice. So sticking with something easy like 0 or 1 will make the workings a bit easier for you. But bearing in mind you now know what a and c are. So it will still just be a linear equation in b. The other method is equating the coefficients. Where we can equate the coefficients of x squared, x, and the constants. And that will give us three equations in three unknowns, which you can use your calculator to solve, or you can solve it yourself if you want, bit of substitution and brute force. I'm actually going to use a former of these two methods for this question, just because I don't have a calculator to hand, and I can't bother to solve three simultaneous equations. So we're going to substitute in x is minus 3 on 2. Now to make this and this 0. And that's going to give us 9 on 4 times 6, which is going to be 27 on 2. 13 times x, so that's going to be minus 39 on 2. Minus 1. That's 0, that's 0. And minus 3 on 2 minus 2, well that's 4 on 2, so it's going to be minus 7 on 2 times c. I'm going to take that and multiply it by 2, so that's going to be 27 minus 39 minus 2 equals minus 7c. That's minus 12 minus 14 divided by minus 7 gives me that c is 2. The next obvious choice is to choose x is 2, because that will make this bracket 0 and this bracket 0. So 2 squared is 4. 4 times 6 is 24. Plus 2 times 13, so it's plus 26. Minus 1. And that's going to equal 2 times 2 is 4, plus 3 is 7. 7 squared is 49. That's going to be 49a. And of course those two are 0, so I can ignore those. 24 plus 26 is 50, minus 1 is 49. 49 divided by 49, I get that a is 1. Now at this point, as I said earlier, there's no obvious choice as to what to choose next for your x value. So I'm just going to arbitrarily choose x is 0. As long as it's not one of these two values, it'll work. X is 0 is nice and easy to work with. So it's minus 1 on the left. That's going to be 9a, but we know that a is 1, so that's 9. Minus 2 times positive 3, so that's going to be minus 6b. Minus 2c, but I know that c is 2, so it's minus 4. Minus 1 minus 9 is minus 10, plus 4 is minus 6, divided by minus 6, I get that b is 1. And that gives me my three values, a, b and c, and then I can conclude. So therefore 6x squared plus 13x minus 1 divided by x minus 2 times 2x plus 3 squared is identical to 1 over x minus 2 plus 1 over 2x plus 3 plus 2 over 2x plus 3 squared. Okay, that's substituting my values of a, b and c that I got from my calculations into my original identity that I created up here. So a is 1, b is 1 and c is 2.